So we will start a new lesson in circles. Now first we'll start with theorem. The angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. So instead of arc we can make it even chords. So instead of arc, so we will take it as chord, whether it's arc or chord. No. No. By the theorem, what it says, the angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. And if two chords of a circle are equal, then their corresponding arcs are congruent. There is a definite correlation between the chord and the arc. Now, in this case, we will take the three types of as shown in the diagram are possible. Now, the arc or the chord, PQ can subtend angle. What is the angle? POQ at the center. The first case, now arc POQ subtends angle POQ. So now we'll take A is any point and the remaining part of the circle. Diagram now in the one POQ is acute angle. In diagram 2, POQ is the diameter. In the next case, POQ is obtuse angle. So in all the case, the center O will join with A, and what about now we can relate now OA, O, P, O, Q are all radius or of equal length. So that in the triangle, so what is the conclusion in the triangle OAP? The interior angles are equal as marked. OAP is equal to OPA. Angle OAP is equal to angle OPA. And similarly, angle OAQ is equal to angle OQA. Now in this both the triangle AOP and AOQ. So these first radius, these two sides are equal length. So subtend equal angle. So they are isosceles triangle because OAP and both these are all isosceles triangle. Two sides are equal, therefore two angles are equal. So what about angle BOQ? Angle BOQ is equal to angle OAQ. plus angle OQA, sum of the interior angles. Oh, the small construction here we have made here the first here we have not made. So extend the line AO to meet the triangular B. Or you make any point, extended way. So what about angle BOQ? BOQ is equal to sum of the two interior angles OAQ plus OQA. Now this both OAQ and OQA are equal is equal to twice, you can say 2 times QAO angle. So similarly, if we see the other side, angle BOP is equal angle AOP is equal to 2 times OAP, angle OAP, or you can say angle BAP. So if we add these two, 1 and 2, if add this 1 and 2 result, so we get angle POQ is equal to 2 times angle PAQ. So in the third diagram, the angle P, it is not PAQ. Sorry, the angle POQ, it is exterior angle, the greater part. So in this third case, this is X, that's why it is marked like that, you know. So we call it reflex angle POQ. So normally POQ, we may take it as interior angle. Now in this case is exterior angle or the reflex angle of POQ. That's the only change. You have to mention specifically POQ reflex angle. The third case. Next, there are angles in the same segment are equal. Angles in the same segment are equal. So what exactly it means? Angles in the same segment are equal. So, so let us take it as this ABC. ACB is a segment. So you join any part of the circle, the angle is same. Angles in the same segment are equal. You join this point, point this point, point this point. So this angle is same in any point of circle, either that side or this side. This side is different. In the same segment, angles in the same segment are equal. Next theorem, if a line segment joining two points subtend equal angles at the other points lying on the same side of the line containing the line segment. The 4 points lie on a circle. That is, what do you mean by they are concyclic? So they lie on the circle. If a line segment joining 2 points at equal angles. So now we'll just draw the diagram for this problem. So what exactly is a line segment joining 2 points at equal angles at other points lying on the same side of the line? So let us take one line, whether on card, a line segment joining 2 points of equal angles of C. So let us take it subtends some angle. We don't know what is the angle. So let us take this uh, line with as AB. We mark the CD. What the problem says, if line segment joining 2 points upon equal angles at other points lying on the same side of the line containing the line segment, one side. Now, what he says, angle ACB is equal to angle ADB. Then these 4 points lie on the circle. That is, they are concyclic. So how to prove? So let us first just draw the circle for example. So the 3 points ACB, we can draw a circle. 3 points can be non-collinear points. We can join and make it a circle. And let us assume D is little outside or inside the line. So let us assume the point D is just outside this circle point, or it can be inside also. Here the D can be here. Let us say the actual point here meets is D dash. Now, as per the theorem above, this chord AB make equal angle at any point in the circle. Now, what is given? ACB angle is equal to ADB. But let us say, let the circle meets AD or extended at D dash. Now, as per the theorem, ACB, angle ACB, because it is lying on the circle, is equal to AD dash B. By the theorem, the chord makes equal angle at any point in the circle, lying in the same side of the circle. The line contains. So in this we are talking about. So what is the theorem? If the line segment joining 2 points at an equal angle at other points lying on the same side, then that point should be in the circle. So what is given in the beginning? Angle ACB is equal to ADB, and now by the theorem, so it beats the circle at the point D dash, then angle ACB is equal to 2. So 1 and 2 are possible only when D coincides with D dash. So hence prove. This is possible only when D dash and D coincide. Now next theorem. So, it's about a quadrilateral. A quadrilateral is cyclic if all its vertices lie on a circle. A quadrilateral is cyclic if all its vertices lie on a circle. That is the definition. Suppose so we will draw a quadrilateral. A quadrilateral is cyclic if all its vertices lie on a circle. So if each one of its vertices lie on a circle, then it's called cyclic quadrilateral. So, next theorem will come. What the theorem says, the sum of either pair of the opposite angles of a cyclic quadrilateral is 180 degrees. So first we should know what is a quadrilateral, what is cyclic. Now we know both. It lies on a circle means, so these two properties are combined now. The sum of either pair of opposite angles of a quadrilateral is 180 degree. So now we will mark this quadrilateral A, B, C, D. So what it says, sum of the angle of the opposite is angle D and B. So what it says, angle D plus angle B equal to angle A. So this is A plus angle C equals to 180 degrees. Now how we can prove this? So take the center point, we can prove it, center point O. How we can prove? This can be proved by just joining this DB and AO. Now we will do some construction. Now we will join O with B. So all the 4 points we will join with the center O. So what is the purpose? Now we know AO is equal to OB is equal to OC equal to TO or radius. Now what about the angles? This CAOB is a isosceles triangle. So these two angles are equal. AOAB is equal to OBA. Now what about this OBC? In this triangle OBC, so we'll mark this two times. This OBC is equal to OCB. This is again an isosceles triangle. What about the angle ODC? So this we will mark a different color, just to identify. What about this ODC? So we will mark 3 times, is equal to here. We mark it 3 times. Similarly, what about this angle? This triangle AOD. So this will mark like this. We know. So just how to add now? What about we will add angle A plus C? So we will see each type 1, 2, 3, 4. If we add, so if A plus C is 1 plus 2 plus 3 plus 4, this is this way, this is this way, this is this way, this is this way. So what about same B plus C, B plus D, same ditto. So angle A plus C is equal to angle B plus D. So it's equal to, how is 180? So all the 4 put together is 360 degrees, 4 angles, quadrilateral. So it's 360 degrees. So 360 divided by 2. So A plus C is equal to 180, B plus D is equal to 180 degree. This we can write in word. We can write, We have just measured in the diagram 1, 2, 3. How we can write? So we can say angle OAB plus angle OAD plus angle BCO plus angle OCD equal to, so we'll write the angles of B and D. Angle ABO plus angle BOC. So sorry, it's not angle B. Angle OBC. It should come in the middle. Plus angle ODC plus angle ODA. So these two are simply angle D. These two are angle B. These two are angle A. So these two are angle C. So a quadrilateral is cyclic if all its vertices lie on a circle and the sum of either pair of opposite angles of a cyclic quadrilateral is 180 degree. So we have combined those two problems. Next theorem. If the sum of a pair of opposite angles of a quadrilateral is 180 degree, the quadrilateral is cyclic. It is just a converse of theorem 5. This we can prove in a similar manner. No, you draw a quadrilateral, a circle. So sum of angles 180 degrees given. If it is a quadrilateral also it's 180. So we can prove the opposite two angles, is equal. We can easily prove this theorem. If the sum of pair of opposite angles of a quadrilateral is 180 degrees, the quadrilateral is cyclic. This theorem we can prove, in similar way where we have proved. Yeah, this question number 3 we have proved the point D may fall a little outside this side or that side, but it is on the line AD. So D and D dash will coincide. The similar way we can prove this. So in this lesson, what are all things we observe? So we are concerned with the angles subtended by the arc at the center is double the angle subtended by it at any point on the remaining part of the circle. Is one number one. So angles subtended by the segment are equal. Angles subtended in the same segment. So either should be in the upper segment or lower segment. One, angles in the same segment are equal. So if a line, next theorem, what it says, so it's about cyclic quadrilateral. If a line segment joining 2 points subtend equal angle at the other points lying on the same side of the line containing the line segment, the 4 points lie on a circle, or it is so it's property of the circle, different property. So a quadrilateral is called cyclic quadrilateral if the four vertices lie on a circle, and if we next theorem combine if the sum of opposite angles of a cyclic quadrilateral is equal to 180 degree, and next theorem is just reverse of it. If the opposite angles of a quadrilateral is 180 degree, then the quadrilateral is cyclic. That is, cyclic means they lie on the circle. Now, thank you for listening patiently. Please go through this theorem and make a small note of it. What is the point exactly they are trying to convey? And remember the theorem, and we can apply this theorem in the problems and solve.